Okay, how does the system work? The high frequency DC power to the heating coil is provided by these ZVS unit purchased from Amazon for, I think, $35. It is rated for 1000 watt. DC power is fed to this from a 24 volts 15 amp power supply. When the unit is running annealing 308, the draw on the power supply slightly exceeds 15 amp. So a 20 amp, 24 volt DV supply is recommended, or you can go to higher voltage like 36 volts. The anneal time will be faster, but then the amperage will be higher. So if you go to 36 volts, likely 20 amp power supply will be needed. So the system is activated by this motion detector. So it's essentially two LEDs, one transmitting, one detecting. It's costs about 10 cents each on Amazon, but you have to buy 50 of them. Once the brass is inserted, the detector then sends logical high to this Arduino unit. Okay, so this Arduino unit then sends a control signal to an optical isolator chip. Okay, so on this side, it's power from Arduino, it's 5 volts. On the other side, it's 19 volts provided by an old computer power supply. Okay, so once the signal is given to the optical chip, then current is activated on the high voltage side, the 19 volt side, and that sends the signal to this solid state relay. The solid state relay then turns on the power from the 24 volt supply to the ZVS unit. Now, once annealing is done, the Arduino sends a control signal to a second optical isolator chip, and that then sends a control signal to a solid state relay, and the solid state relay then sends a control voltage, I think it's 12 volts, to this solenoid. Okay, the solenoid essentially retract a slider. You know, a slider here that holds the brass up. It's very quick. The solenoid is only activated for 100 milliseconds. That's enough for it to quickly come back and let the brass drop. So the Arduino is powered, I think, at 5 volts, and the power is supplied from the 19 volts through the buck converter converted to 5 volts. Okay, the second buck converter converts the 19 volts to 12 volts to power the water pump and the heat exchanger coolant fan. Okay. So an advantage of using an Arduino versus a relay timer is you have very precise control. So you can control the timing of the heat cycle to 0.01 or even quicker. Most of the timer type of relay, it has a resolution of 0.1 second, and the 0.1 second really makes a lot of difference. So it's really 0.05 second control is very useful in providing the precise temperature to the brass. The Arduino can also offer future possibilities in automate the annealing process. For example, you can use it to drive an auto feeding system, and it can also likely be used in the case of my system to attach a stepper motor here. Then once you select the brass type, the system could automatically change the the elevation of the supporting platform, the brass supporting platform to the correct brass. Okay. So far, the system works pretty good. The coil, I think it's about 0.6 inch ID, I think 10 turns. Heats up slightly because of there's no water reservoir here. So all the water is only a few grams of water in the tubes. So it heats up slightly. This coil becomes a little bit warm after annealing about 30 brasses. But it doesn't get very hot because once this warms up, then the heat is removed from the system, from the heat exchanger. Okay. In fact, I think the limiting part in terms of how quickly you can anneal, probably these capacitors. After annealing a combination of about 30, 308 and 556, the capacitor gets pretty hot. So if you want to anneal brass quickly, it's likely you'll need a cooling fan to keep the capacitors cool. So this is essentially how the system works. I will briefly, I guess, display the circuits that I generated for this, as well as video the Arduino program used to drive the system. So this box is approximately, I think, 13 inches by 9 inches by 9 inches high for your reference if you want to build something similar. Thank you.
This is an incomplete schematic of the circuit used to control the power and to eject the brass. But the main components are here. All the switches you saw in the front panel are depicted by this part of the circuit diagram. Essentially, if the switch is connected, then you get 5 volts, and this 5 volts gets sent to the input pin on the Arduino. Unfortunately, TinyCAD does not have Arduino Uno, so I'm stuck with Arduino Mega here. But the pin assignments are the same. The proximity sensor is this little schematic here. Essentially, it's powered by 5 volts, okay? And then if an object is in front of it, it generates a signal that goes into the Arduino. The Arduino send control signals to these two optical couplers. So this is the optical coupler for the solenoid. So from pin 4, send the control signal here, light up the LED, and then the started conducting, and then it send a signal to this MOSFET here that turns on the solenoid. Okay, and the second optical coupler is for the CVS induction module. What you saw on the video is not a MOSFET like this, it's a solid state relay. I had originally intended to use this, but it was drawing too much power and overheated, so I purchased an external solid relay, but works essentially the same. Now this has 3 leads, the external one has 4, but that's only isolate the MOSFET that's embedded in the solid state relay. This is the code to control the Arduino. So this code is not well organized. The variable names made them up as I went along, so it's needs a little bit cleaning, but it works. So I'll scroll down so that you can see the whole code if you want to replicate this.